Hi everyone, welcome back to Java Full Stack Flow. Today microservices interview question is, what is load balancing in microservices? This is one of the most frequently asked Spring Boot Microservices interview questions. Let's understand it step by step with a real-time example. What is load balancing? Before understanding load balancing, let's imagine a simple scenario. Suppose your application has only one instance of the order service. If only 10 users access the application, there is no problem. But imagine during a sale 30,000 users place orders at the same time. All requests go to the same server. That single server becomes overloaded. As a result, response time increases, users experience delays, some requests fail, the server may even crash. To solve this problem, we create multiple instances of the same microservice. Instead of running only one order service, we run 3 or more instances. Example, order service instance 1, order service instance 2, order service instance 3. Now we need someone to distribute incoming requests among these 3 instances. This is called load balancing. Next is, how does load balancing work? Let's understand the complete flow. First step is multiple service instances. Means, suppose we have an order service. Instead of running only one instance, we run multiple instances. For example, order service instance 1 10.0.0.1:8080, order service instance 2 10.0.0.2:8080, order service instance 3 10.0.0.3:8080. Here, why do we create multiple instances? Because if only one server handles all requests, it can become overloaded. Multiple instances allows us to distribute the workload and also provide high availability if one instance fails. Next is step 2, register with Eureka server. When each order instance starts, it automatically registers itself with the Eureka server. It sends information such as service name, IP address, port number, health status. Eureka keeps track of all available service instances. If any instance goes down, Eureka automatically removes it from the list of healthy instances. Next, third step is client request service. API gateway or another microservice requests the required service. Example, order service. Means now a user places an order from the mobile app or website. The request first reaches to the API gateway. The API gateway doesn't know which order service instance should handle the request. Instead of using a fixed IP address, it asks the Eureka server. For example, give me all healthy instances of the order service. Next, fourth point is Eureka returns healthy instances. Eureka server returns the list of all healthy instances. For example, 10.0.0.1, 10.0.0.2, 10.0.0.3. If one instance is down, for example 10.0.0.2 is down, so Eureka won't return it. Next, fifth point is load balancer selects an instance. The load balancer selects one instance using algorithms like round robin, random, least connections, and etc. Means it selects one instance using a load balancing algorithm, for example using round robin. Request 1 instance 1, request 2 instance 2, request 3 instance 3, request 4 instance 1 again. This ensures that requests are evenly distributed. If you are using least connection, the load balancer selects the server with the fewest activity request. If you are using random, it randomly picks one healthy instance. Next, sixth point is process the request. The selected instance processes the request and sends the response back to the client. For example, it validates the order, stores order details in the database, and sends a success response. Finally, the response travels back through the API gateway to the client. From the user's perspective, everything happens in a few milliseconds. Next is, now let's understand the architecture diagram. On the left side, we have the client or another microservice. Whenever the client wants to access the order service, it doesn't directly call any order service instance. Instead, the first request goes to the API gateway. The API gateway acts as the single entry point for all incoming requests. It can perform tasks like authentication, rate limiting, logging, and request routing. Next, the API gateway contracts the Eureka service registry. The Eureka server maintains a list of all healthy instances of every microservice. Eureka server continuously monitors whether the registered services are running or down. Suppose the order service has 3 running instances. The Eureka server returns the list of those healthy instances to API gateway. Now the load balancer comes into the picture. The load balancer the list of healthy instances and selects one instance using an algorithm such as round robin, random, least connections, or weighted round robin. Finally, the selected order service instance processes the request and sends the response back to the client through an API gateway. This architecture improves performance, high availability, scalability, and fault tolerance because no single server has to handle all incoming requests. Next is load balancing algorithms. Round robin. In round robin algorithm, requests are distributed sequentially across instances. Next, in random, requests are sent to a random instance. Next, in least connections, requests are sent to the instance with the least active connections. Next, in weighted round robin, requests are distributed based on weights assigned to instances. Next is interview answer. If the interviewer asks what is load balancing, so you can answer like this. Load balancing is the process of distributing incoming requests across multiple instances of the same microservice. It improves performance, scalability, availability, and fault tolerance by ensuring that no single server becomes overloaded. In Spring Boot Microservices, service instances are discovered through Eureka and requests are distributed using a load balancer such as Spring Cloud LoadBalancer with algorithms like round robin or random. That's all about load balancing. If you found this video is helpful, please subscribe my YouTube channel and follow me on Instagram for more real-time Java full stack interview questions. Thank you.